Hi, my name's Stuart Lynch, and this is a continuation of the Xcode SwiftUI workshop. In the first video of this series, we introduced Xcode and the Xcode interface so that we could get an understanding of how it is laid out and how we can manage the different panes. We also learned some keyboard shortcuts and took a look at the content view struct by adding a number of different Swift views or controls to the body of the content view to see how they are positioned in the preview canvas. In this video, we'll begin coding our first application by creating our user interface, or the UI. And this will be for our How Much app, where we want to enter a value of a restaurant bill, the tip percentage, and the number of people attending so that we can calculate each individual's portion. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. In the first lesson, we created a new app and we called it How Much and started testing those different layouts. And that's what you're seeing here. If you don't have this application started, please create a new iOS app and call it How Much. So in the case of a new application, your content view will look something like this. Regardless of where you are, we're going to start by removing all of the content within the body and start from scratch. We'll get some errors, but those will get resolved shortly. So let's start by creating a shape that we can use for our button. And I like to prototype right in the SwiftUI view. So we can open the library and drag out the button onto the code editor and place it within the body. The string for the label is simply button, but we want to change that to be the number 7, still within quotes because the label has to be a string in this case. And we'll leave the action for now. Buttons, like other views in SwiftUI, can be stylized by applying a wide range of modifiers. We can start with a font modifier, and it requires an argument that specifies a font type. Well, in SwiftUI, there are often a set of default values, predefined values, that you can work with, and these are accessed by simply typing a period. And then the one that we want is large title. We can also apply a font weight to our label, but for this we can use a shortcut, which is simply .bold. Next, we can apply a background that again is a modifier that requires an argument. So we can use that dot trick again and see that Xcode and SwiftUI has to offer us perhaps a color. So let's choose purple. Let's add a frame around this so we can use a frame modifier and specify a width and height of 80. Now this is not quite what I wanted or expected, but it's because the frame is added after the background has been applied. So we'll need to create that frame beforehand. And we can move up complete lines of code up or down in our code editor by selecting the line or lines and then using keyboard shortcuts, which in this case are Option, Command, and then left square bracket is going to move it up. A Option, Command, right square bracket would move it down. Well, this is better. But now let's add a foreground color, which requires a color, so we'll use .white. And now this is looking closer to what I want, but it's a square, not a circle. Well, we can fix this by applying what's called a clip shape that will clip the view to the shape applied. And the shape that we want to apply is a circle view. Well, this looks pretty good, except when I tap on the button, only the text fades, not the entire button. I want the whole button to react when I tap on it. Well, why is that? Well, because the action visual only affects the label, and that's that single string. The modifiers are applied to the entire button. So this requires a different button constructor, and this is one of the reasons why I don't like to use the library. I prefer to start entering code to see what my options are. So let's comment out this code. And you can do that by selecting the lines of code and then typing command / And this tells Xcode's compiler to ignore all that text. It puts 2 / in front of every one of the lines. So we don't have any buttons now. So below the commented out text, we'll start by typing button again. And then with the left bracket, you'll see that we have a lot of options that we can explore. And the default one is this one here that the library offered, where we have something that conforms to a string protocol and then our action. So if we chose that, we can see that we can replace the string protocol with anything that can be enclosed within quotes, like our 7. And then if we tap enter on our keyboard, that action label and the closure turns into what's called a trailing closure of just a pair of braces waiting for our code for our action. So let's erase this code now and try again. The second most common type of constructor for a button is one that is more powerful. You choose action first and then label. And this will allow us to create a more creative label for our button. We can hit enter on the action and it will remove the action label and leave the closure for our code, but then add a second trailing closure for the creation of our label. Well, for this we can use a text view that requires a string for its label. So let's just use 7. Well, let's cut out the modifiers that we applied to the whole button in the original example and paste them as modifiers for our text view, and then reverse the commenting by selecting that code again and once again typing command /. This is looking better. The code's not aligned though properly, but we can quickly fix that by selecting any text and then typing Control-I on my keyboard. Now, as you can see, the entire button is active when I click on it because it's the entire label. Then we can remove the remnants of our old button and the blank lines, and then do another Control-I to clean up our alignment of this misplaced line. So we can stack 3 buttons horizontally by embedding them within an H stack and then just change the text string for each one. And the easiest way to embed views in another container view is to select the text and then enter a left brace. All container views use a left and right brace to contain the content. Now, once we've done that, it's contained and all we have to do is specify what that container is, and it's an H stack. And then we can duplicate this entire button 2 more times and simply just change the string to represent our different button labels. This is repeating code, so why not create a function that will allow us to pass in a string to be used as the label for our button, and then return that button, which is some kind of view. So let's use cold folding to fold our H stack up now. And then I'm going to create a function outside of the body, but still within the view struct. That function is going to have one parameter, and we can use the label number, but that number is actually going to be a string, and it's going to return some view. Then we can copy one of our buttons and then just paste it into the body. And then, instead of always using that same string of 7, we can replace that with the number variable, which is a string. With that function created, we can replace the contents of the H stack with 3 calls to that function, and then passing a different string value for a number each time. Well, we can even do better than this, and we can use what's called a for each loop. And a for each loop will iterate over a collection or a range so long as the collection or range are unique, and that then will provide you with an iterator. So in our case, the range is going to be from 7 through 9. So we create a closed range by using 7.9. We'll need to specify, by way of an ID argument, what the thing is that is unique about the range. Well, in this simple case, we can use the key path of .self. So we'll use /.self to represent the actual range item itself. And then when I tap on the content placeholder, it replaces that with a trailing closure and the placeholder for a variable name that we can use in our closure to create our view. And this variable we can call number. The code then is going to be the code to represent our view. So we use our number function, which returns a view. But we don't want 3 7s. We can use the number variable to change this. The problem is that the number is an integer, and a text view requires a string. So we can use string interpolation to represent a number as a string by enclosing the variable in quotes, and then the variable within parentheses, and then we can precede that with a backslash. Well, we can stack 3 H stacks vertically within a V stack and simply change the range. So again, we'll just highlight these, use a left brace, enter V stack, and then duplicate it 2 more times, changing the range as we need. For the last row, we'll create another H stack. But the first 2 buttons will be the same as what we've had before, but we can't iterate because one's a 0 and one's a period. So we'll just create 2 number buttons, passing in 0 the first time, and then a period for the second. And within the H stack then for the last button in the row, we can't use a number button because the label isn't a string, it's an image. Well, we can create that button again using the label option, but instead of using a text view, I want to use an image. And that image is going to be one of those system images that we looked at in the last video. So I can bring up the library and the symbol tab, and I'll search for back. And I can find this delete.backward.fill, which is what I'm looking for, and drag it out onto the label. Well, the styling that I want is almost identical to what we have, but the only difference is the background color. So I can copy the style that I have in my function now and paste it to apply to the image view that I have here, but change the background color to gray. Turns out that images composed from SF symbols can be styled exactly the same way as a text view. Below the number entry fields are 2 options: the tip percentage we want to apply and the number of people in our party. So we're going to create a picker that will allow us to update a special type of variable with whatever value we choose. And pickers must be bound to some kind of a variable that can be updated. However, variables in structs are immutable, and this is unless we decorate them with a property wrapper that's called @state. So at the top of the struct, above the body variable, create a new variable called tipPCT and initialize it by assigning a value of 0 and decorate it with the @state property wrapper. Notice my variable name, I'm using lowercase to start and camel case to represent 2 different portions of this actual variable that describes what I want. After the last H stack then, create a picker by dragging it out of the library. And we can change the select from this constant 1 to tip percentage. And this will bind it to that variable. And in order to bind to a state property, we have to precede the variable with a $sign. And I can change the label to text tip. Now, instead of these 2 text views, we can use another for each loop like we did before to specify the range that we want to allow for tips. So how about from 0 to 100%? Of course, this is going to require another ID, which again can be self because it's simply a range. And it'll provide me with an iterator that I can call tip. We'll need to use string interpolation again then. So within a text view inside our for each loop, we'll do a string interpolation on tip. and then add a % symbol. A picker can accept any kind of styling that a button can, and there's a special modifier called a button style for buttons. So I'm going to apply the bordered button style to the picker. And then I'm going to embed the picker and its style in an H-stack, and then add a text view as the first view using the same string tip. You'll notice that the label that's used in the picker is not displayed. This is displayed only if we're presenting this picker in a form. So we'll need to provide our users with another clue as to what this is. Below this, we want another picker for the number of people, so we'll require another state property. And I'm going to call it numPeople. And I'm going to set it to an initial value of 1. Then we can simply copy and paste the previous H-stack, and then we can adjust it to represent our people picker, and we can then limit the range as well to be from 1 to 20. Below that, we want to create 2 buttons side by side that we can display in an H-stack. Well, since the buttons are just strings, we can use that simple constructor to pass in the label as a simple string argument, and the action will be that trailing closure. The first button, the string is going to be calculate. The second button, it'll simply be clear. And then we can create a style for each one of our buttons, but if we apply it to the entire H-stack, it will drill down and apply to both buttons. And that button style is bordered prominent. Above the number pad, we want to create a text view that will display the amount that our bill is as we enter it. Well, this will change when we add each new digit, and we'll need to track that in another state variable. So we'll want our amount aligned to the right. So I'm going to have to create another state property, and for this, since it is a string, because that's what we need for a text view, we'll initialize it as a string as 0 within quotes. Then, as the first entry of the V-stack above the H-stack, I'll create a text view, and I'll simply use that total, which is a string. No need to use string interpolation here because it's already a string. So this time I'm going to use a larger font than what SwiftUI provides. So if you create the font modifier and type in the period argument, you'll be able to scroll down and you'll be able to find one that is called system that takes in an argument that is the size. So we'll select that one and enter 70. So to align it to the right, we'll first have to specify a frame with a specific width because all text views only occupy as much space as is needed. And we can calculate the width that we need to be 3 times the width of each one of our buttons, so 3 times 80, plus the distance between the 2 buttons, which is the default 10 points, so that spacing will be 260. And since, again, they're all aligned to the center, we can provide an alignment to this frame and set it to the trailing edge. And finally, we'll apply a vertical padding to override the default in the V-stack, so we'll specify 1. Now, we're not doing any navigation in this view, but I do like to see a title on my view, and one of the easiest ways to do this is to add a navigation title. But first, we'll have to embed our entire V-stack inside a container called a navigation stack. So I'll collapse the V-stack so I can select it, and then enter the left brace, and then type in navigation stack. I can then collapse the V-stack once more, and still inside the navigation stack, but after the V-stack, I'll create a navigation title modifier and use the string portion calculator. And then I want to do another thing here is that I want to push the entire contents up to the top of the screen. So as the last item in the VStack, I can use a spacer view, and this will take up all of the available space remaining and force the view up to the top. As a last thing, I don't like the blue tint of our buttons or the pickers. I'd like to make a change so that I can have them looking purple like the rest of my controls. So what I can do is I can apply to the entire view, which is the navigation stack, a Tint Modifier and specify purple. Now this isn't necessarily the best place for this, however, since there may be multiple views in our application, and I don't want to have to do this to each one of my views. So when our app launches, the first file it sees is the one marked with the app main property wrapper. And that's the how_muchapp.swift file. And you can see in there that the window group presents content view as our first view. So we can apply a tint here and have it carry through to each view within the hierarchy. If I switch back to content view now, it doesn't appear. Or does it? If I run the app in the simulator, you'll see that it does. And why is that? Well, it's because the canvas preview has no idea what it took to get there. This is just a preview presentation of the code in the editor, and it has no idea that it came from the app entry point. So if you choose to run your project code, it will compile and launch the simulator that, when it's finished loading, will present the content view screen and the tints applied. Now these errors you see here in the console were introduced in Xcode 14.2, and I believe it's a bug in Xcode. If you're not seeing these errors, then they fixed this issue. But if you still are, the fix is easy. You can select the application and its target, and select the Info tab. Drop down the little triangle beside the Application Scene Manifest line, and then select it and tap on the plus button. If you run the application once more, you'll find you have no more errors showing in the console. Now, if you want to see what it looks like in the preview as it did inside the simulator, we can apply all modifications that we applied to content view in our entry point to our preview provider as well. So down in the preview provider, we'll just set the tint to purple, and now we see what it looks like. In testing, I see that I've made one mistake here. I don't want to start my number of people picker at 0. I want to start it at 1. Well, that completes our UI for now. We still have to code the actions for each one of our buttons, and that's what we'll do in the next video. And then we'll finish off this tutorial in the final video by creating another view that pops up from the bottom so that we can view our tip and per portion calculations.